Hey everybody, it's Wojo. Today we're going to continue our work on solving equations. Today we're going to look at the distributive properties. So let's go ahead and get started right away and take a look at the kind of problems we're going to be solving today. So you should have some experience with problems that look like this. So hopefully this is just a little bit of a refresher for those that might not have understood it last year. Hopefully this is a time for you to get really good at it. So let's say we're solving a problem that looks like this. It says solve 4 times the quantity. So these parentheses means we're multiplying the 4 by everything in here. 4 times the quantity, 3k plus 4 equals 64. So the first thing you should know is what does it want us to do? What does it mean to solve? It means we got to think of the number, or not think of, we're going to actually work backwards to find the number that we're going to multiply by 3, then we're going to add 4 to it, and then we're going to multiply that by 4, and our final answer should be 64. So we're going to need a number here. So 3 times 2 is 6, 6 plus 4 is 10, 10 times 4 is 40, that doesn't equal 64, so the k value couldn't be that. So we're going to, instead of just guessing, we're going to try to solve. Now we've talked before about solving. We want to try to get the variable isolated, so we want to get things away from the k. We don't care about anything past the equal sign, so all those solving rules still remain the same. We're going to only look at things on the same side as the variable. Remember, the variable is a fancy name for the letter. And so we're going to say, all right, who's bothering that k? Well, we have a plus 4, so we're going to have to do some kind of subtraction at some point. We have a times 3, but then we also have this 4 out here that's getting multiplied to all of it. So normally we would say, well, if the problem just looked like this, we would just say, well, let's get rid of the plus 4, and we would subtract 4 to both sides. But that really isn't just a plus 4, it's also going to get multiplied by that 4 out here. And so this is where that distributive property comes into play, that we know that parentheses mean multiply, and so we're going to have to multiply before we even start this problem. So we're going to start and say, well, who does this 4 get multiplied to? The 4 gets multiplied to both of the things in here because the parentheses are around both. If I just wrote this 4 like that, that means 4 times 3. If I wrote 4 times 2, that means 4 times 2. If I wrote it like this, that means I'm going to write or multiply the 4 times the 3 and the 4 times the 2. Now back in grade school, you might have did the 3 plus 2 first and changed that into a 5, and then did 4 times 5 equals 20. What you're going to realize, though, you could do it the distributive property way and multiply them separate, and you would get the same exact answer. 4 times 3 is 12, plus 4 times 2 is 8. 12 plus 8 again is equal to 20. So we could multiply these out, which is helpful because in a problem like this, like here, 3 plus 2 is 5, we know we can't add 3k plus 4. They're not like terms, so we can't add them together. So we need this distributive property to be able to expand this out. And so what we're going to do is come back to the problem now, and we're just going to start by multiplying the 4 by both of these quantities. It's very possible that in the past you've seen teachers draw arrows like this. That's just showing that we're going to do some multiplication. That 4 is going to get multiplied to the 3k, and that 4 is going to get multiplied to the 4. So 4 times 3k is 12k. The way I got that is 4 times 3 is 12, and then the k kind of comes along with it. And then 4 times 4, and one of the things you want to watch is these signs. That 4 is a positive 4. That 4 is also a positive 4. So a 4 times 4 is a positive 16. And we write a positive 16 as a plus 16. This sign will not always come straight down. There will be times that this will be a plus and your answer will be a minus. If this was a negative 4 out here, a negative 4 times a positive 4 would be a negative 16. So don't just get used to copying that down. You want to do that math, figure out what your answer is, and then choose your sign. So 4 times 4 being a positive 16. And then that equal sign comes down. We didn't touch that, and that's equal to 64. From there, we're going to solve just using the same ideas we used in the previous time solving. We're going to see who's bothering the k, and then who's farthest away, and we're going to undo it. So here I have a 12k, which means 12 times k, and then I have a plus 16. So I'm going to have to get rid of a multiply by 12, and I'm going to have to get rid of a plus 16. Now, to decide which one we get rid of the one that's farthest away from the k. So these are kind of attached together. So the plus 16 is farther away. That's pretty close. It's farther away. And so we're just going to undo it. To undo addition, we subtract. So we're going to subtract 16 from this side. And to keep it equal or fair, using that subtraction property of equality, to keep it equal, if you think of a scale, if I subtract 16 from one side and it was equal, to keep it equal, I'm going to subtract 16 from the other. So we're going to do that. If you need a calculator, use your calculator on your phone, use your calculator on your Chromebook, whatever calculator you have at your house, that's fine. So I'm going to have 12k that comes down. So this we didn't do anything with, so that's still on the left-hand side. 16 minus 16 is 0, so I just cancel it out. That's what that mark is me just saying I don't need to worry about it anymore. Equal sign comes down, and then 64 minus 16 is 48. And so I get a brand new equation that says 12k equals 48. And then from there, I still have to ask myself, am I done? Well, how do we know we're done? Is k completely by itself? Nope, we still have that times 12. So now we got to get rid of the times 12. To get rid of a times 12, or a multiplication of 12, we're going to do the inverse operation, which is division. So we're going to use the fraction bar to show division. So you're going to see me write that. That means divide. We don't really use that symbol very much anymore. We use the fraction bar instead. And again, to keep it equal, if I divide the left-hand side by 12 and I want it to stay equal, and I do want it to stay equal because of that sign right there, I have to divide by 12 on the other side. 12 divided by 12 is 1. 1 times anything keeps it, so if it's 1 times k, it's still going to be k. And so again, I can use that to say we could pretty much ignore it. And then we still have the equal sign, and 48 divided by 12 is 4. So I get an answer that says my k value that worked in this original equation should be 4. I can always go back and check my work by rewriting the original equation, which was 4 times 3k plus 4, and plugging in 4 for the k value. So everywhere I see a k, that means I thought it was a 4. So if I said, well, what's 3 times 4? That's 12. 12 plus 4 is 16. 16 multiplied by 4 does give me 64. So I know my answer of k equals 4 is correct. All right, now that you've seen me do a problem, let's kind of work a problem together really quick. So just kind of follow along. If I gave you this problem right here, solve negative 52 equals negative 4 times 1 plus 4r. And I asked you, what would you do first? So now that you've seen that and you're looking at this problem, would you know where to start? So what would you do before you did anything else? Well, I hope that you look at and notice that there is an r, so there's our variable. So we're going to have to get r by itself. So we don't care about things on this side of the equal sign this time. So this time it's on the right-hand side. And I hope you would notice that there's these parentheses. And so before I can do much, it would be nice if we distributed that negative 4 out. So I'm hoping that when you looked at that, you would say, well, I guess I got to start by multiplying this negative 4 by both of these quantities. Again, this negative 52 is still in the problem, so we're going to still have it. Equal sign is still there. And when you go to distribute, remember, what does this mean? What do these parentheses mean? Those parentheses mean to multiply. Well, who are we multiplying? The negative 4 by both of these. So negative 4 times positive 1. Remember, a negative times a positive is still negative. This says plus 4r, but after I do my multiplication, what kind of sign am I going to get? What is a negative 4 times a positive 4? Remember, this sign goes with that number. So negative times a positive is a negative 16. So how do I write a negative 16? We're going to write that as a minus sign. So negative 16, and there was an r value in there. So after I distribute that problem, I end up with a brand new equation. And that's really what solving does, gives us new equations. So now, if I asked you, are we done? Did we do the whole problem? Did we do what we were intended? Did we solve it? No, because solving I should end up with an answer that tells me what my r value is equal, and I still have a whole bunch of things bothering this r. So if I asked you, where would you start next? What would you say? Well, I'm hoping you would notice that there is a negative 16 multiplied by r. Notice what kind of 16 that is. It's not just a positive 16, it's a negative. So I'm going to have to do some division to get rid of that. But then I also have this negative 4 out there. The one that's farthest away is the negative 4. And so we're going to start here by getting rid of that negative 4. So in math, the inverse of a subtraction or a negative is to add. So to get rid of a negative 4, I'm going to add 4. Now where else are we going to add 4 to keep it equal? Well, we just added 4 to the right-hand side of the equal sign. So now we've got to add 4 to the left-hand side. Now be careful with these negative numbers. In algebra class, we're going to use a lot of negative numbers. What's a negative 52 plus 4? So you owed someone $52, but you just gave them 4. You're still going to owe them money, but you owe them less money. So negative 52 plus 4 is negative 48. And if you need to use a calculator, that is all right. Equals negative 4 plus 4 cancels out. That was the whole reason we did that. And don't lose this sign. What kind of 16R was that? That was a negative 16R. And I always go back to ask you, are you done? Well, how do we know if we're done? Well, you know you're done if the R is completely by itself on its side of the equal sign. And right now it's not. It still has that times negative 16. So we got to get rid of a multiplication. So what undoes, or what's the inverse of multiplication? That's going to be division. Remember, we write the division bar. So I say, well, how do you write that? You write it as the fraction bar as negative 16. And then because I divided by negative 16 on this side, I have to be fair and divide by negative 16 on that side. At this point, we're just doing math. So just look at what you have here. What does that mean? Negative 48 over negative 16. That just means we're dividing it. So negative 48 divided by negative 16, a negative divided by a negative is positive. 48 divided by 16 is 3. If you didn't know that, that's all right. You can use a calculator for it. And on this side, because the negative 16 divided by negative 16 is just 1 R or R would be my answer. Now, am I done now? Well, again, how do we know? Is there anything left bothering the R? Nope, it just says R equals 3, or in this case, 3 equals R. So we could rewrite it as R equals 3. Either way is fine, but we know the value that we would need to plug in here to make this equal was an R value of 3. Just like before, we could check our answers. I'll leave you to check it just to make sure, but that's kind of our process in going through a problem like that. All right, so we'll leave you with just this one last extra example. I can let you guys try this one out if you like. If you want to pause it and try the problem, see if you're going to get stuck somewhere. That might be a great way to practice before you try the practice problems itself. See if you could figure it out, because you might just forget or kind of get stuck on what it should look like. And then so trying it by yourself would be nice. And then you can come back and look to see how you did. If you feel like you're good, then you can just keep playing the video and watch it from here, and we'll go through and make sure you're good to go. All right, so we'll kind of speed run this one just to make sure. Hopefully you tried it on your own. You got an answer. You started, you noticed the parentheses, so you distributed. 7 times 7 is 49. I have the x there, so it's 49x. 7 times negative 6 is minus 42. Again, positive times a negative makes a negative, so hopefully you have a minus 42 there. Still equals negative 336. Now our goal is to get x by itself. There are two things bothering the x, the times 49 and the minus 42. When we try to make a decision on which one to get rid of first, it's usually easiest to get rid of the one that's farthest away. So the times 49 is only that little distance away. The minus 42 is a much bigger distance, so it's farther away. So we're going to get rid of the minus 42. So hopefully you added 42. Now, if someone's going to make a mistake, often they make a mistake in these calculations right here. So their algebra is fine. It's just they made a mistake with arithmetic. So don't be afraid to use a calculator just to double check the work here. Negative 336 plus 42 gives me an answer of negative 294. So I'll write that in there. And then at that point we have to get rid of the times 49, so we divide by 49. And again, I'm not really sure what that is, so if I use a calculator, I already have that in there. I can divide by my 49, and I get an answer of negative 6. So if you tried this problem on your own and you had an answer of negative 6, great job. We'll have you try some problems, and if you have questions, like always, just reach out and message us, and we'll be more than happy to help. Have a great day, everybody. Talk to you guys soon.